So far, we've seen that we can register our providers within a providers array, and the providers array exists on components, directives, modules, routes, and the application config. But there's one other array where we can register our providers, and that array exists only on a component, and it's called viewProviders. The viewProviders array is a group of providers that can be accessed by the children of a component, but only if those children appear within the template of the component. Therefore, projected components do not have access to the viewProviders array. Let's take a look at this in our demo application. Here in our demo application, let's add a providers array and a viewProviders array to our display component, and let's have both of those arrays replace the display service with the simple service. So first I'll add the providers array. And I'll copy this and add a viewProviders array. And to the providers array, we'll register a provider that provides the display service and replaces it with, let's do use factory. And let's replace it with a simple service, an instance of a simple service. And of course, we have to add the source info. So we'll say source from providers. And let's add a similar provider in the viewProviders array. And we'll say source from viewProviders. Now notice what happens in the browser. The display component itself is using the provider that's registered in the viewProviders array. But the other display component, which is a child component, and it's also a projected component, does not use the viewProviders array. It uses the providers array for its display service. And that's because projected components do not have access to viewProviders, only child components which appear on the template of the parent component. So with that in mind, let's go to the template of the display component and let's add an other display component. And we'll have to add that in our imports as well. And now notice what we have. The other display component, which is in the template of the display component, does receive its display service from the viewProviders array, because child components, which appear on the template of the parent component, they do have access to the viewProviders array. Here's one thing you probably also noticed is that the display component itself is using the viewProviders array over the providers array. You would think that it would have access to either of these, but when both are available, the component itself will use the viewProviders array. Now, one other thing that I do want to show you is that the access that child components have to the viewProviders array is also impacted by a resolution modifier. So if we go to the other display components and we add a resolution modifier, let's add both the optional resolution modifier and the self resolution modifier to the other display component. Notice our application appears to be broken, but in actuality, it's not broken. There is no error. And if we open the console, we'll see that there is no error. The reason there's no error is because we're using the optional modifier on the other display component. If we remove the optional resolution modifier, we will indeed get an error. And we get an error because there's no provider for display service. There's no provider for display service because the other display component is using the self resolution modifier, which means that there has to be a provider for display service within its either viewProviders array or providers array. Other display component cannot reach the viewProviders array that its parent is providing because of the resolution modifier. So again, we have to bear in mind that it's a combination of where the provider is registered along with any resolution modifiers that controls whether a component has access to a given resource. By now, it should be obvious how components and directives traverse the hierarchy of injectors. But I also want to make you aware that services also traverse the hierarchy of injectors. So to do that, let's first clean up the code a little bit. I'll remove this self modifier from the other display component as well as this import. And let's go back to the display components template and remove this extra other display component. And let's also go back to the display component code and remove both the import. And let's also remove the viewProviders array. We'll keep the providers array, but instead of hard coding the source for our simple service, let's instead use source token, which if we go back to the simple service, we have an injected source info token. So let's create a separate dependency for this token. And we can do that by, in our use factory function, we can pass the source parameter. And now we'll need a dependencies array. And let's use the source info token. Now, of course, this is going to break our application because we have no provider for the source info token. So let's create a provider for this source info token. Let's first create a provider in the app config, in the application config object. So we'll add a provider and we'll provide source info token. And we'll use value, and we'll let that value be source from root. And now we see that both the display component and its child component, its projected child component, are using the simple service, which is registered in the display component, but the dependency for the simple service is in the root or app config object. Now, instead of using the app config to register our source info token, let's provide for the source info token inside our providers within the display component itself. And we'll say source info from display component. And now notice that both the display component and its child other display component are using the provider for the source info token that's registered within the display component. So the simple service has a dependency. It's a source info token. And the registration of this simple service is within the display component. And simple service, in the same manner in which a component would traverse the hierarchy of injectors, so too do services traverse the hierarchy of injectors. So first, simple service tries to resolve its dependency for source info token within the providers where it's registered. And it finds it. It finds it here in the display component. Now, again, if we remove this registration of the source info token, then the dependency for the service will traverse the hierarchy of injectors until it reaches the root, in which case we see that both display service and its child component resolve the provider of the source info token in the registration at the root level. Before we wrap up our series on Angular Dependency Injection, I do want to touch upon use cases. I did purposefully begin the series in part 1 with discussing real-world use cases of dependency injection. But now that we've gone through all of the different features, such as injectors and hierarchy of injectors and registration and resolution modifiers, you might be wondering, why are all of these different features necessary? Where would I ever use any of these features? And when I began to learn about the various features of dependency injection, I asked those same questions. But essentially what I found is that you as a developer will come up with a number of ways in which you can use things like resolution modifiers in your own code. Essentially, it's not knowing about these features which causes us to either duplicate code or create situations in our code where things are hard-coded and not really extensible. It's not knowing about these features which put us at a disadvantage. But now that you do know about all of these features, you've gone through the entire series, I'm pretty sure that you as a developer will come up with different scenarios where some of these features of dependency injection will become invaluable to you. So with that, I hope you enjoyed the series, and please do subscribe to the Angular at Work channel to receive notifications on further series and Angular features that we'll be covering. Until I see you in the next video, happy coding.